Hello, 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 hello. Hi, everyone. Let's go and do our worksheet for today. Okay. So this is a series diverge or converge. The prompt is apply divergence test and integral test or the limit comparison test. Okay, so we're going to do the divergence test first. Extract just the series in the sum. And we know that this limit does not exist. So therefore, if it does not exist, then by the divergence test, the sum diverges. Okay. All right. Number two, does the series diverge or converge? And we have this expression. Notice how it starts at 3, by the way. That's going to technically be important for later. So you do the limit as n goes to infinity of ln of n over n. That's infinity over infinity, so you can use Hopital to help you out. 1 over n over 1, which is 1 over n, which that limit is 0. So this doesn't tell you anything. So you can write divergence test is not conclusive. So then you do the integral test. So for the integral test, you set it up as 3, because we start at 3, to infinity of ln of n over n. But, oh, you have to check if it's positive, decreasing, and then continuous. So here we're starting at 3. So really we're just checking if it's continuous from 3 to infinity, which we know that would only be continuous if it touches 0. It doesn't, so it is continuous. And it is positive. That value will never be negative. This value will never be negative, so it is positive. But is it decreasing? Let's go ahead and just actually find the slope, m. F is this prime, we get 1 over n times n minus ln of n times this third, which is just 1 over n squared. So that becomes 1 minus ln of n over n squared. So we know that will be positive, but this guy up top, that's going to be what determines if it's negative. And really, this expression, if it's negative, it's less than 0, but really, we're saying 1 is less than ln of n. And the way we can determine that is if we pay attention to domains. Don't forget, you're technically in the realm of 3's and above. So if you start with your n being greater than or equal to 3, or by this point you could also be saying x, but I'm just, should do x, because you do change the function notation. Greater than or equal to 3, then if you take ln of x, and ln of 3, I know you don't get 1. Where's my phone? Oh, where did my phone go? Yeah, I'm just gonna go ahead and use. I guess my phone. Okay, let me go ahead and just use my handy dandy computer. Just write ln of 3. Hello. Okay, and it says ln of 3 is 1.0986, which we know is greater than 1. So therefore, this ln will always be greater than 1, so that checks out. So it is decreasing. All right, so then we could definitely use this. Forgot to rewrite in terms of x dx. We know that this is a u substitution situation. Of u, or u is ln of x. And then du is 1 over x dx. So we have 3 infinity u du. So that's just, oh no, not this anymore. Oh, I forgot to replace the limit. T3. It's an ugly 3. And now I can go ahead and do the integral. U squared over 2 for t and 3. I can factor out the 1/2, but I'm already seeing what's happening. Because you'll have t squared minus 3 squared, which is just 9. But either way, this polynomial will be going towards infinity. So the whole thing would be going towards infinity. So via the integral test, this diverges. Diverges via the integral test. Because if the integral wasn't able to give you like an actual value, then the sum will not give you an actual value. So therefore it diverges via the integral test. Okay, over here we have 1 over square root of n. I'll check if it diverges first, parsing the divergence test. Limit as n goes to infinity of 1 over n square root. This is just a situation where the bottom is a positive power, so we know that limit will be 0. So divergence test is not conclusive. But here we can use the logic of the p-series. So p-series states that if here, let me actually just get our notes for that, just so I don't misspeak. P-series states that when you have a series in this form, which we technically can rewrite this to be 1 over n to the power of 1/2, and p is greater than 1, then the whole series converges. But if p is less than 1, and by the way, p is positive, and either greater than 1 or less than 1, then if p is positive and greater and less than 1, then it diverges. So we see here that the scenario we're in is that it diverges because p is less than 1. It's for 1/2. So therefore, the answer is diverges using p-series ideas. Okay. Now, the last one. Okay. The last one states, does the series converge or diverge or converge? Let me see. Okay. The series converge or diverge? For here, we can see that this is going to be the limit comparison test. So while an will be this full expression, bn can be just the leading parts and an n to the power of 3, which I will simplify this time to be 1 over n squared. Now here, the sum of bn, which is the sum of 1 over n squared, is gonna be is gonna converge because p is greater than 1. Okay, so if p is greater than 1, then you're going to go ahead and see if this guy converges. Because if this converges and we divide the two and we get a non-zero L, then this guy will match this result, which is converging. So let's go and do that. We have n plus 3, n3 plus 2 divided by 1 over n squared, which we can write that as n plus 3 over n3 plus 2 times n squared is equal to n3 plus 3n squared over n3 plus 2. In that case, we can see that the limit here as n goes towards infinity, for this, it's a balanced equation, so it's just 1. And 1 does not equal 0. So therefore, these guys have to match. So via the limit comparison test, our original sum converges. Okay, let me just look around here just in case. You could also have determined that this diverges via the integral test as well. I just chose to rewrite it as a P series just to practice. Yeah, that's pretty much it.